Yes. Okay, we have a MacBook Pro. It's an A1278 and it says dead, which is no power. Let's let's see what we're dealing with. Okay, back cover is out. We can confirm that this is indeed a 2012. Um, you can confirm that from the board number, which is 820-3115. You can confirm that from the drive cable type. You can confirm that from the screen connector on the screen cable. Okay, so this is a low power. First and first, let us connect our charger. We can see that it doesn't seem like a liquid damage device, so it is safe to connect our charger. Let's connect our charger to see what we get. Do we have communication? We have communication. Do we have fan spin? We don't have fan spin. So because we have communication, two things has been confirmed. PPDC in, it's present. PP3V42, it's present. So what the next thing we want to do is let's disconnect our charger and then disconnect our battery as well. By the way, from 2011, so because from 2011, the charger without the battery connected, the charger is able to start your device. So if I connect the charger, it should start the device if the device working condition is complete. Okay, so we are now starting still. Let us see what we have on our PPBUS. We confirmed that we have PP3V42. This is going to be an 80-3115. Let us open up the board view. 80-3115. Okay, this is our board view. Let's flip to the other side. So let's start by making measurements on the PPBUS. We can confirm that on F7040. Let's see what we have on our PPBUS line, which is F7040 is going to be this guy here. Let's see what we have. Let's try that again. We have 0.42, and then on the other side 0.42. Okay, so we don't have PPBUS voltage present. The next thing we want to do is we want to see if we have a short on that line. Let's switch to continuity mode, see if we have a short on that line, and we do not have a short. Okay, that's fine. So what we want to do is before we continue, let's see if we have a short around our ISL, which is going to be responsible for generating PP bus voltage. That is U7000. Let's see if I have a short around it. Okay, so we don't have a short around our ISL. The next thing we want to quickly do before we do anything else is to replace our ISL and then take it up from there. Okay, that's let's get a donor board. Do we have an ISO here? We do, but we're not sure if this has been used. Okay, in any case, let's just try it. We don't know if the ISO here is good, but we can try. While replacing the ISO, you have to be mindful of its orientation, especially when you are transferring from a different board other than the board that you're working on. So pin 1 is going to be on the small dot here. I'm not sure if you guys are able to see that. So here it says pin 1, and on the chip itself, you have a small dot that indicates where pin 1 is. And let's replace, let's put it back. Okay, that's installed. Let's put this here since we're yet to confirm if the ISL is faulty or not. You can always remove it when you confirm that our problem is indeed the ISL. Okay, so let's disconnect our fan. First, I want to see what I have on my PPBUS line before. Let's see what we have. Do we have PPBUS now? Okay, it seems that ISL is completely bad because we don't even have communication on our charger. Okay, that ISL is bad. Let's get another one. So without the ISL, you see that you should have charger communication without the ISL. See, that's charger communication without the ISL. So let's get another ISL for it. Okay, we can use that one from here. Suppose it should be good. The machine for Ezekiel, the A for no power, is it still here? Okay, that is installed. Give it a bit of time to cool off. While we're waiting for it to cool off, we also want to see what we have on the current sensing line. First, we'll clean that section of the board. And then we want to see what we measure on the current sensing line. So the current sensor line, we're looking at a R7021 and R722, as well as R7020, R7052, and R7051. So let's switch to ohms mode. That's fine. That's fine. That's fine. And then the other side. Okay. Okay, that seems just fine. Let's see what we have on our charger now. Do we have PPBUS, or do we have to take the board out? Okay, something is going on with the PP with the second ISO can number 40. Okay, the second ISO can number 40. Let's see, do we have PPDC in? Say, do we have PPDC in? We have PPDC in. PP342. We don't have PP342. Do we have a short on PP342? Let's see. Do we have a short on PP342? We don't have a short on PP342. Okay, so let's quickly take our board out. It's very unlikely that both ISLs are faulty. So let's take our board out to get an idea of what's happening. Okay, board is out. Let's put the shell on the side. Let's get an idea what's happening. Yes, go to the other side. It's quite some dust. Let's dust the board. Let's move our speaker. Okay. So let's see, what do we have? Okay, so let's try again. Let's connect our charger and see. We have charger communication. No charger communication. Okay, fine. Let's see what we have on our PPBUS. PPDC in. can measure for PPDC in here. 16, that's fine. PP3V42, not present. Okay, let's work our way to PP3V42. Let us open our schematic 820-3115. 820-3115. Let's quickly come here to our DC jack. So, and then we start from the beginning. So DC jack is going to be J6900, which is where the charger gets connected. Let us go to J6900, J6900. Okay, so our J6900, this is going to be the point, that's our DC jack. That's the point where our charger gets connected. So whatever say, so right now we the voltages on our PPDC in is going to be here, and obviously it goes through that line, it goes through to the fuse. We want to see where PPBUS is going to be generated, PP3V40 is going to be generated, so it's going to be generated here, which is at U6900. So before we continue, let us remove the ISL and see what happens. Obviously, remove the ISL because it's not possible that that both ISLs are faulty, and also the ISL that was there before, we had PP3V42 present. So the first ISL we have PP3V42 present, and the two ISLs that we have installed now, we somehow not have PP3V42. So something is happening with the ISL being installed. What we want to do now is, now that ISL is out, let's see what we get. I mean, before we were getting communication on the charger with ISL not present, that's fine. And then now we should have PP3V42. Just confirm that. Then we can confirm at this inductor here. PP342, we see that is present, and that's further confirmed because we have communication on our charger. So with the ISL installed, something is definitely happening. So it's either we have, I mean, it's very much unlikely to have two faulty ISLs, or we may have, it may be that we having a short with the ISL installed. So before we continue, let us measure at the footprints of the ISL. Let's see if we have issue at any of the pin. So let's go back to U7000, which is our ISO. That is going to be the battery charger IC. Now let's see if we have a short on the line. Let's check. Okay, we're getting a beep there. What is that? Okay, that's ground. That's fine. Okay, we don't seem to have anything on the ISL, on the ISL foot. So let's put in another one. It's very much unlikely to have two faulty ISL. So let's put in another one. Yeah, same thing. Okay. Okay, that is in place. Okay, let's see, what do we have? Do we have a communication in our charger? Still no PP342. Okay, we got something very interesting is happening here. That is the third ISL. And okay, let's see. Diode mode. Zero 035. Orientation of the ISL is definitely correct. It's close to impossible to have 340 ISLs on a row. Let's try that again. We have PPDC in voltage. Yes, we do. PP3V42. We don't have PP3V42. Okay. But without the ISL, we have PP3V42. We checked on our ISL footprint. it's impossible that we do not have. Okay, let's uh, let's just install one of the ISLs that didn't work on the board here. Okay, let's take out this DC jack here. Yeah, we definitely, this is then let's see, do we have PPBUS here? It's measure for PPBUS. Can just measure for PPBUS. Yes, we do have PPBUS. So the problem is definitely not the ISL that we are installing. The ISLs are fine because that's the ISL that we pulled out from one of the boards and it still didn't work. So definitely we're having something more than just an ISL. So what we want to do now is find out what is happening. We have to build up why we do not. Let's put back this ISL here. And just what we also would like to do is let's put back the one ISL that actually worked on it, but we didn't have PPBus. Let's see that. Okay, that's in its place. Now let's go back to the board. So we have to work our way around. Is the DC jack? Okay, yeah. How are you? How is work? Okay, so we confirmed that. Okay, let's now see what's happening. Let's see what goes into what is going to our ISL and what is going out of our ISL, and then we take it from there. Connect our charger. Okay, it's almost like it tries to start and then it stops. So what we want to do is, let's see what goes into our ISL. Let's start charger gate. Let's see what we get there. We can measure that here. 0, that's fine. Let's PPDC in. What do we have? Okay, we have PPDC in, charger AC in. What do we have in charger AC in? 3.9, okay. Voltage, okay, charger V. We can measure that on the other side. Okay. Okay, let's just confirm something here. Let's find. Let's just Go straight to D6990. Let's see what do we have on D6990. So we want to see what we have on R6990 because that's basically the entry point to our PP3 before to circuitry. What do we have on R6990? Let's copy that. Go here. So we're just basically trying to fast forward now. What's happening to you? Close that and open that again. Hold down your software. It's giving us okay, fine. Let's search that R6990, I suppose. And here we have it. That's the resistor. So we're trying to fast forward to exactly what we get in, so we can measure PPDC in there. We have that, we have input, and then we have output. Okay, so let's see, and then our inductor diode, sorry, let's see what we have on our diode. Pin, okay, pin 2 our diode. So we have voltage here. Let's say we have voltage out. Let's see, do we have voltage out? And yes, we have voltage out. Okay, so why do we not have output on U6990? So we go to U6990. So what we have confirmed is we have voltage going through our diode here, and it's going to U6990. So if we see how U6990 is going to work, we have TON, which is basically more like a time on. We have the enable signal, we have the VCC, and then we have the feedback line. So let's see what we have on okay, VIN, which is on pin 7. Yes, we confirm that is present. R6995, let's see, R6995, R6995, it's gonna be, where's R6995? What is it tied to? R69 is tied to pin 3. Okay, let's go to pin 3 here. Pin 3 on the other side of the board. Okay, that's R6995. It is this here. Let's see what we have there. 15, 16. Okay, that's fine. Pin 1 unconnected. Let's quickly go back again. Okay, pin 1, pin 2. That's a feedback line for PPBUS. Let's see what we have on the. Let's see what we have there. 3.8. Okay, let's see. Do we have PPBUS? 0 volt. Okay, 0 volt. Okay. And then that we confirm we have VV in. Pin 4, we confirm that we have that. Let's just confirm that again. Okay, and then wait, I just got 2.5 volt. We did confirm that was present before. How is it now we're getting 2.5 volt? Let's see the. Okay, now we're getting also 2.5 volt at the beginning of our inductor. Sorry, of our diode. Wait, what's happening? Okay, let's check the resistor. 2.5 volt. Okay, what's happening? 2.5 volt. Okay, let's disconnect and connect again. Let's check again. 16, okay. 16, okay. So we confirm we have 16. We have our input. PPTV3 underscore switch. Let's see what we have there. That we confirm we don't have that on our inductor here. we have 0 volt, and we also confirm we don't have a short. We have confirmed that. Okay, we already confirmed that's present. Feedback, we confirm that. PPBUS pin 9, okay, we've confirmed that it's not present. And then pin 10, let's see, pin 10, other side. Okay, let's see what we have on pin 10 on C6996. Okay, 0. Okay, so it's a bit of a tricky one because without the ISL, PP3V42 is present. With the ISL, PP3V42 is not present. So we cannot blame our PP3V40 circuitry just yet, because when the ISL is present, we have ISL being present, we have no PP3V42, but without the ISL, we do have PP3V42. Okay, let us clean a section of ISL. Let's see, what is it that we are missing? Is it sending a cable or what? Uh, so as we can see, we have a 3.4 volt with the ISL installed. So what we want to do now is let us okay, let's do this. Where's our ISL? Where's our ISL? So let's go to U7000. Let's work out from there. Let's go to U7000. So U7000, that's our U7000. So let us see what's happening with Q7030 and Q7035. So Q7030 and Q7035 are going to be, that's Q7030 and Q7035 on the other side of the board. Q7030, Q7035, where are you? Q7030 and Q7035, let's quickly search that. Q7030 and Q7035. Okay, so let's say that because we have already confirmed we don't have a short on our line, on our ISL, on the ISL foot. Let's remove the two resistors. Sorry, transistors. Okay, these two transistors are out. Let's put back our ISL. Okay, so without Q7030 and Q7035, we want to see what reaction we get on the board. say that is cute, I think. Okay, see what reaction we get on the board without Q7030 and Q7035. Okay, so without Q7030 and Q7085, we have PP3B42, and that we can confirm because obviously we have indication on the charger. That's 3.4, 3.5. Let's see, 3.5. Okay, it's a little weird. Are we getting 3.5 on a 3.4? Okay. Okay. So without Q7030 and so okay. So let's first get a donor board to replace those first, and then we can let's see. Did you come with anything? What did you come with? Talk to me. Let me see. Yuri, what time is it? 5:10. Okay, I need to leave. Which one is urgent of the two? What's the MacBook Pro? You say it's a no power. Okay, and the air. Do you want to wait for the Pro? Uh, okay, let's see what will happen now. A GoPro, yes. GoPro, yeah. I need to. Okay, so now we have replaced Q7030 and Q7035. So with those, let us see what happens with both transistors replaced. So there's two MOSFETs here, Q7030 and Q7035. So, but just before now, as we saw, with those MOSFETs installed, we didn't have pipet. So basically, the reason why I had to come to these two MOSFETs here was because, so each time the ISL gets installed, PP340 is not generated, but before when it's out of the board, we get PP342. And now I'll build up to that. Before that, the reason why we came here was because we didn't have PPBUS, and those two MOSFETs plays a major role in generating our PPBUS because they are going to do the switching on and off, and obviously ISL is going to do the control, and then we obviously would then get an output of a 12 point something volt, which is 12.6 volt after the process is complete. So we didn't have PPBUS at first, and then when we tried to replace the ISL, with ISL replaced, we didn't have, now PP34 also was gone. Then we could confirm that everything in this section of the board, just it's fine. Everything here, it's fine. But because I mean Q7085 is definitely opening, Q78 is definitely opening, but what we kept getting was with ISL installed, PP340 will disappear. So then I thought, okay, fine. what is it that, so I had to kind of break it down. Okay, what is before and what is going to be after. And the only thing that I saw that would be after all of that out of the picture would be Q7030 and Q7035. Now with both of these out of the board, we saw that now we have PP342 being generated. And also, like I said, we couldn't blame the secretary for PP342 because without the ISL, PP340 was being generated. So there was no reason for us to blame the PP340 generation circuitry with ISL installed. So Q7030 and Q7035 we remove, and then we see that we have PP342 now being generated. So after that, on that line, on the line of Q7030 and Q7035, we don't really see anything else that may be an issue. This is an inductor that's basically very dependent on, so this, it's not going to fail in the type of, even if this fail, we will not have the reaction that we're getting now. And obviously and definitely it's not going to be a fuse. So we may have, let's okay, we have replaced both. Let's see what we now get. uh let's see, do we see have PP342 or do we have to, yeah, let's see if we have PP342 first. Okay, so we're having the same issue. So the next thing we want to do now is we want to remove, but we did already confirm that we don't have a short on our PPBUS. Okay, let's just check. Let's just confirm something again. Connect the charger. Let's see what we get. Okay, so what we want to do now is we want to, let's go to L7030. So let's see what and what is it's connected on that line. On that line, okay, that is connected to the charger first, that, okay, and then that. This is definitely not an issue because Q7080 is working just fine. Okay, so let's do this. Let's go to R7020. R7020, it's going to be, where's R7020? It's this guy here, R7020. So let's take out R720 from the board. Or what we can just do, it's we can go to okay, first of all, let's see what happens without, the fuse here. Let's take the fuse out, F7040. Let's take it out of the board and see what happens. Because we see here, that's basically the start of our PPBUS where it says to the system after it's been generated. Let's take that out and see what happens. And so because it's a fuse, whatever happens on pin 1 of it, it's going to happen on the pin 2 of it, because that's a fuse is like a wire. So okay, so our fuse is out. Let's see what we have now. We yeah, the reaction we're getting, even if we do have a short on our PPBUS line, we should not be getting our PP342 line being okay. So the fuse is off the board and we are getting PP342 rail is being generated. Okay, now let's see, do we have PPBUS on pin 1 of this? So if we do, that means we have a problem starting from the pin 2 of the fuse. So let's see what we have. Do we have PPBUS on pin 1? And we have PPBUS on pin 1. So our problem is from pin 2, so which means on the other side we have a problem. This is very interesting. So we have a problem from pin 2 of, obviously, of the PPU. So on the system side. Now, what is it that is, and then we can, we just confirm now that we also have PPBUS on pin 1. PPBUS is present at 12.5. What is that on pin 2 of our, I mean, what is that on the system side that is basically pulling our Okay, so let's see what is happening on the system side of our PPBUS. That we obviously switch our multimeter to diode mode, red probe to ground, and then a black probe on pin 2. What do we have? 0448. That is not a short. So what is it that it's um, okay, that's not a short. So let's just confirm that. So yeah, that's not a short. So let's see. Hmm. What is it that it's missing with? Hmm. What is missing with us? What is missing with us? What is missing with us? Uh, what is messing with us? Uh, 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 uh. Okay, let's do a bit of a visual inspection here. Let's see what could be messing with us. Let's also do a bit of a see if we have any short on the board. Okay, so far we don't have a short. Hmm. Okay, so we do not have a short on the board. So okay, so what we want to do now is we want to before we put back the the fuse, let us send voltage to, let's see, let us put voltage to our board on the PPBUS side, on this side, the system side. Uh, it's interesting what's happening. We don't have a short, and PPBUS it's with ISO present, you get funny behavior now. PPBUS. Obviously, PPBUS not being generated, and also PP342 also don't get generated. Okay, so let's try to gradually let's put voltage to that side of the. Let's see what we get. Okay, let's see. Switch to voltage mode. 1.3. Hmm. 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 Is anything getting hot? See if anything is getting hot. On the other side of the board, let's remove our heatsink. Okay, let's see. See if anything is getting hot or warm. With the amount of power that we're putting through the board, we should be getting something crazily hot. But we still don't get anything hot yet. Okay, we're getting heat on this side of the board. Let's see what that is. There's so much power going through the board, but we don't get anything getting hot yet. Hmm. Something getting warm in this section of the board. So this cup here, this cup here, it's crazily hot, and this one here, it's super hot. Okay, and then second one, so they are both okay, so this and that. So let's see what those caps are for. mm, these are going to be, this is a very very interesting one. So that's going to be okay, so that's not good. That's not good. So what we want to do, it's, so these are really really hot. They seem to be okay. So let us, so that's going to be, let's go to Q7020. Let's see what we have on Q7020. Q7020, Q7020, Q7020. Q7020. Are we on the right schematic? Yes, we are. Q7305. That's Q70. No, Q7220. Oh, Peter. Q7220. You just look here. Ah, okay. U70. Okay, 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 okay. Okay. So what we want to do is okay. Let's do this. Now we want to see if our problem it's okay. Okay, Q7020. That's those are the caps that are getting hot. So what we want to do is we want to remove L7220 and then put back our fuse and see if we have a problem on, but that's L7220. We checked that we didn't have a short there either. L7220, let's see, L7220. Okay, let's, L7220 is going to be this guy here. Where is L7220? 7220 here. Okay, let's check again. We checked, we didn't have a short on that line. Let's check again. Do we have a short on that line? We still don't have a short on that line. Okay, so what you want to do, let us put back the fuse and then remove Q7220 from our board and see what reaction we get. Okay, so now let's come to, and another possibility, it could just be that the amount of power that we're putting through was higher than what the caps are rated for. That's just why the caps they're heating up, not because there's a problem on that line. That's another possibility. Because I mean we don't have a short on that line, so I mean it didn't make sense for. Okay, so what we want to do now is let's see. Do we have, is our ISL short back down, or do we have at least see what we get on our ISL? Okay, so that's good. Now let's see what we have in our PPBUS. PPBUS. We definitely have a problem because PPBUS is okay. So PPBUS is being pulled down. Okay, let's remove this guy here. Let's check out PPBUS again. At least our ISR is no longer okay, so that's not good because that guy. So this it's so if with that removed, so it means okay, we need to plug. Please, can I have charger from my bag? There. No, the three MagSafe 3. Yeah, and the brick. Okay, that's not a good thing because it's not a good thing. It's not a good thing. Okay, let's see. Okay, we have. Okay, let's put back. Let's put back. Where is Q7220? Where is Q7220? Where did we put that? Under the board. Peter, where's Q7220? I don't understand. What are you saying if you don't see it? I guess it fell. Peter, what are you saying if you don't see it? Peter, I don't. If Peter don't see it, I don't understand it. Okay, so I'm just gonna. I will be. Did you see it? Okay, let's grab another one. Okay, so um, R5410. It's wait. No. So actually, because our PPBUS was reading what 2 point something volt, yeah, and this is basically our 5410. It's more like a bridge between the PPBUS because here and then in PPBUS and then the other side of our so let's go to R5410. We get a better idea. R5410. R5410 current sensing resistor. Okay, where is our R5410? Where is it? Okay, here it is. Yeah. So here we have in. So this is going to be the in and okay, it's okay. So our PPBUS is obviously coming in from here, from the pin 2 side of it, this side, and then the other side goes to this section here. And those two caps that were heating up, they are on that line. So I think we now have to remove those caps because we were thinking that perhaps the amount of power that was going through was higher than what the caps are rated for. That's why the caps are hitting now, but it doesn't seem like that. So let's remove those two caps because we we that resistor so yeah, so let's take out those two caps. And on that line, let's see what is on that line. So on that line, you also have your U7200. Okay, so because what will happen, it's up until the pin 2 side of it, which is going to be the input side of it. You will have voltage, which is here, and then once you put that there, when it crosses to that side, then you have a problem. Okay, so let's remove those two caps. We're gonna use okay, we can just, those caps are gonna pop because that's let's remove those two caps, expecting that the caps will pop. Yeah, yeah. So with these caps, really, when you want to remove them, you don't hit them directly from the top, otherwise you get a pop like that. So you wanna do like a side heating kind of thing, but yeah, just it's fine. We can get some pop in. It's fine. Yeah, thank you. Okay, that's out of the board. The next thing we want to do it's so at least we are kind of making way. I mean, we are closer to where our problem is going to be. Before we put those caps back, let us see what we have. That's not the only thing on that line. We have more, but these are the two caps that we're hitting up. So on that line, we have Q7220. Even with the Q7220 off the board, we're still getting the same drop, voltage drop. Like a massive drop. On the other side, on the PPBUS. So we have Q7220 as well, and we also have U7200. So first, let's put this back and see what we if we without those caps. Let's see if we have any changes there. If we don't, then we have to keep removing some of the components on the line to finally see where our problem is. Okay, that is there. Now, what do we have? Charger. Okay, charger is fine. Okay. What do we have on our PPBUS line? 2 volt or 12 volt? Let's see. Okay, that's looking good. 12 volt. Okay, now what we want to say is what do we have? Do we have voltage and okay, let's see. Do we have voltage here? That looks good. Do we have voltage here? Okay, our board is starting. Okay. Uh, we will go to that. We'll get to that. But generally, the caps on a line like that is going to act as a bit of generally a bit of a battery kind of, which is to hold power, and then a bit of smoothing out the line, and a bit of ripples, making sure there are no ripples on the line. But they are not critical. So what that means is, even without the caps, we can still run the machine. Um, but right now we just gonna do this. Let's just confirm that our board is starting, and then we can now replace those caps. We see that we are now in SO. Okay, So our fan is spinning. So the next thing we want to do is let's at least see if we have image on our screen. Uh, it's been quite a journey until we got here. Yeah, it's been quite a journey. So okay, let's see what we have. Let's see. I'm still going to. So usually two ways you want to troubleshoot this to get to see if your device is if the board is posting. You can connect a speaker or you can connect a screen. So connecting speaker, obviously, when you get the chime, I mean that gives you okay, yeah, your board is definitely posting because you got the chime. But sometimes, depending on the settings of the machine, you may not get a chime, and that may not tell you. But when the device is posting, you would definitely with the screen connected, you can definitely get something on the screen. Okay, yeah, so we've got a chime and then we also got something on the screen. So I should be expecting a question mark folder on our screen. Peter, are you able to get that? Okay, so yeah, so we're just waiting for a question mark folder on our screen. This is quite an interesting. I mean, the behavior of the board was. I mean, imagine ISL bin and PPB42 pinch. Okay, so that is. You guys see the. So yeah, so that's a working board. The next thing we want to do is we want to put back those caps, and then like I said, even if we don't have the caps, that will be fine. But let's put those caps back. So, but this was really interesting. Yeah, this was yeah, I keep tripping. Uh, it's really interesting. Okay, so let's grab those caps from the donor board. You want to do that from the other side of the board. Okay. We don't want the caps to pop because we just want to reuse them. So this was very interesting. I mean, PP, look at that. No, man, it shuts PP342 down and then that and then yeah, yeah, and they're very far from where we were picking the problem from. Very far. I mean, we have to keep building up and then like, I mean, how do you all the way from east you coming to make problem in the west? This is this was an interesting one. Really, really interesting. Uh, really interesting. Orientation for this is important. You see the color markings. It's important that you keep to the orientation. Okay, let's put that back. Okay, this was an interesting one. Okay. out of time. I'm not gonna have the time to go over the summary of what we did. I guess I'm just gonna write like a do like a written summary. Yeah, we do that while with the video posted because it's time for Salah now and I need to go. Now, by the way, you send Mark. You send him 1850 on the 1502 invoice. Mark, and then you can inform him that it's ready. 1850. And then also find out from him. You ask him if you would like you to wait for him or you collect tomorrow. Did you finish testing the screens? Peter, are you doing thorough testings? Tell me, did you find anything working yet or all of it?
There's one that showed the display without any correction. No, it came on with one. So it's a king.
Yeah, you see, you saw how I told you about, I mean, how you can go over the cables. Otherwise, you won't. Most of the ones that will have no image at all is going to be an issue of the cable, like the flex cable. Is one interesting repair. The way it's, I mean, somebody leave their own locality to come cause problem and that. Other locality. So you have to that machine for Pascal. Try it again, say, and then you can, because the owner is on their way to collect the machine. So okay, guys, cleaning is done. This repair is complete. I will see you guys in the next one. We will not have time to do like a recap of what we did because of time. But yeah, I mean, you guys saw that we have Apple logo, machine starts, and no, not Apple logo. We've got a question mark on the which indicates that we are obviously device is starting. So I will see you guys in the next one. This is gonna go through the assembly phase and then get tested, and then yeah. Thank you guys. I will see you in the next one.